Assalamualaikum. My name is Muhammad Irfanuddin Mizanuddin. Today, me and my teammates are going to present our final results for FEA analysis of a bike frame. Next. For our simulation overview, we uses the NCS workbench to run our simulation, and the material that we chose is the carbon fiber reinforced polymer (CFRP). And the load cases that we analyze is the rear seat load, front seat load, and the middle handlebar load. And lastly, the scenario that we chose for our bike frame is flat, uphill, and downhill conditions. Next.
Uh, Hello, my name is Aceh Daniel Melvin Majingol, and now I'm going to talk about the downhill condition, which is actually our critical case. Now this is our bike frame. As you can see, the forces at the three areas, that is the handlebar, the middle seat, and also the back seat. And from the results that we gotten from NSYS, maximum deformation about 0.0275 millimeter, and the minimum of deformation is negative 0.1088 millimeters, with an average of negative 0.0050 millimeter. And for the strain, of course, we get the maximum 9.535 times 10 to the power of negative 4 millimeters, with average of 9.39 times 10 to the power of negative 5 millimeters. Now, for the stress von Mises, we've got a maximum stress about 197.89 megapascals, with about average of 19.86 megapascals. And lastly, about the safety factor of the whole bike frame, we've got the minimum part of the safety factor, which is about 6.5292, and the maximum of safety factor of 15. Next. Okay, now for the flat and uphill conditions, mostly the max stress, minimum safety factor, and maximum deformation is around the same. Around max stress is 197.89 megapascal. Minimum safety factor is around 6.5292, and maximum deformation around 0.0275. All in all, they're all the same. And the deformations are minimal, so it means that it has excellent stiffness. And nextly, we're going to talk about the pictures below, which is the forces direction in each part of the three loaded conditions. Now, as you can see from the flat part, uh, the handlebar, the middle seat, and the rear seat are all facing downwards because it is a flat condition, a flat terrain. Now, next is the uphill direction of force. Uh, all in all, they're the same, but the only difference is the frontal handlebar, which is the force going backwards due to it being inclined, makes the force going back. That's why the force in the front is facing at the rear. Okay, next. Now let's move on to the critical loading case. And from the report and data we have collected, we chosen around downhill condition. Why downhill condition is critical is because the highest horizontal load is at the handlebar, which is around 200 newtons, and combined vertical loads from both riders. Of course, this is a tandem bike, and also dynamic stress due to descent motion. Okay. Next is the design focus, which is the reinforced joints, bottom bracket, and for future tests, the model should model vibration and increase fatigue. Next.
Okay, Assalamualaikum. My name is Nadir Rafiq. Surimin. Okay, I want to talk about the parametrics studies summary for the tube size diameter for 33 mm. The safety factor is 6.53. For 30 mm, the safety factor 4.91. For 26 mm, safety factor 2.3. For 24 mm, the safety factor is 1.96. Minimums for the 2 to is the safety factor 1.14. And lastly, the 221 the safety factor is 0.8, 0.98, means unsafe. For the conclusion, means the 24 is the minimum safe diameter, and 26 or more for rider safety margin mean not safe. Okay, next for the final conclusion is first the CFRP tandem frame design is structurally safe under all tested condition. Second, downhill scenarios is the most demanding and should guide design. Third, frame geometry can be optimized down to 24 but 26 is recommended for reliability. Lastly, FEA enable high confidence prediction without the cost of physical prototyping. Okay, that's all from my group. Thank you.